Nice. Yeah, so this is the part of analysis video, and this video is the final one, talk about differentiation. So this video, let's talk about differentiation on a vector values. So differentiation on vectors, on vector value function. Okay, so suppose, so remember that our definition is AB from open interval, a closed interval to R, then we can define derivative. Right, so suppose you have f1, f2, up to fn, then some people will just write a vector f to be AB mapped into Rn, and this f have each component is f1, f2, f up to fn. Then the f prime is just defined to be another vector, which is f prime, f2 prime, fn prime. Okay, so you might think, oh, it's trivial, or whatever, right? Yeah, this is definition. Okay, so what's the point? Okay, so what's the point? Okay, so the point is that in the vector value, both L'Hopital, okay, so both L'Hopital rule and the MVP mean value theorem fails. Okay, so remember the MVP is basically FB minus FA equals A prime of C, B minus A. There exists a C in AB. Okay, the L'Hopital rules, one baby version is that if these guy both are zeros, then then you just compute this guy, right? And if G prime is non-zero, then this guy will be this guy. It's just a baby version of L'Hopital. But in the vector value, both of these two will fail. Okay, so example. So this is just the final thing I want to say. Okay, so let's working on MVP because MVP is simple. So let's consider f of x to be, let's say we're using complex number, right? So let's define real to be C2. Oh, sorry, C. Let's say cosine x, right, plus I sine x, right? So everybody knows is it. So the differentiation will be minus sine x, I cosine x, or just I exponential ix. Okay, so obviously you see f2 pi minus f0, which is what? It's 0, right? Because this is a periodic function. But your f prime is the absolute value is 1, right? So there's no way. That this guy will equals to f prime times 2 pi, right? Because this is 1. Okay, so the mean value theorem fails. Okay. And now the fail of L'Hopital. Yeah, I mean, I don't want to write name. So let's consider our input, our 0, 1, and also working in a complex. Let's say working on C. So f, we just define f of x to be x. Should be simple. And define g of x to be x plus x squared is equal to I divided by x squared. So this is open interval, right? So don't worry about when x equals to 0, this term will blow up. Okay. So obviously your fx divided by g of x, let's say let's working on this. Okay, so this guy is what? It's x divided by x squared plus exponential I divided by x squared x, right? So this is 1 x plus exponential I divided by x squared. Oh, sorry, this is x squared, this is x. So I'm stupid. This is 1, this is x. Sorry, let me just clean it up. Okay, so this guy is okay. 1 plus x is equal to I divided by x squared. Yeah, and then we let x equal to 0. So x goes to 0, right? So you can bound this term because it's equal to I divided by x squared is less or equal to 1. Oh, sorry, it's just 1, right? For x become real. So if you approach it to 0, then it become 1, right? So this is approach to real 0. Okay, what about derivative? Oh, just finish. Let me just find a place, right? So what about the derivative? So g prime will be 1 plus 2x, 1 minus 2i divided by x is equal to ix squared, right? So the g prime of x will greater or equal to 1 plus absolute value of this. When x take a real, right, I can kill out this term, and this is greater or equal to 1 plus 2x plus 2 divided by x. Let's see. So, wait. Okay, so yeah, so let me just write down. Sorry. So g prime of x. I used the wrong direction of the equality, right? So g prime of x. Let's say so you know that a plus b is greater or equal to is less or equal to a plus b, right? Absolute value by is greater or equal to a minus b. Right? So this is to take absolute value, a difference, and take the final absolute value. So g prime of x absolute value will greater or equal to 1, right? And minus 2x minus 2i divided by x. Just use this, okay? And obviously, you can see that this absolute value is always greater than minus 1. So this is just 2 divided. This is greater or equal to 2 divided by x because you only preserve this term minus 1. Okay. And f prime of x is still very happy to be 1. So your f prime of x divided by g prime of x, take absolute value will be 1 divided by g prime of x. So this is let's see. Greater or equal to 2x minus 1, right? So this term will less or equal to x 2 minus x. So when x approach to 0, you get f prime g prime, which is 0, right? Because x goes to 0. Okay, so fail, right? Because we just proved this guy is 1. So they are not the same. Okay, so finally, let me just prove another thing. Let me just add more. Yeah, so that I can write something. What's going on? Okay, so let's prove the theorem, which thinks that even though the mean field theorem failed, right, but we can still find the sum bound. So this theorem is important. I suppose f is from a b to a real dimension r to n. Let's say r to k. Okay, and f is differentiable on a b. So each component is differentiable. Then there is this x belongs to AB, such that the FB minus f of A is less or equal to B minus A prime of x, take absolute value. Okay, so this is the theorem. So basically, you can still find the x such that the derivative will bounded by can large greater or equal to this. So in the one dimension, you can make this to be equal sign, but higher dimension, you can only say that the equality. Okay. Approved. Yes, let's see the proof. So the proof is very easy. Let's write z to be f of b minus f of a. Right, so z is a vector, and then you consider phi of t to be z in the product with f of t. So how about phi of b minus phi of a, right? So this guy just write this, right? So let's see. So right, so this is, so remember this phi is a one dimension, right? So it's this phi is from a b to r. So one can use this guy, the mean value theorem, right? So there is the c. Let's say use x, right? There is this x belongs to a b, such that this is phi prime of t, b minus a. Okay. So notice this phi prime of t It's just so z is a fixed vector. So phi prime of t will be z dot with f prime of t minus a. Sorry, this is x. I'm stupid. X. Okay. Phi of b minus phi of a. Okay. So once you have this, yeah. So this is one result, right? And another result is that if you just see a definition, this z dot with f of t, so your phi b will phi of a is just f of b minus f of a, right? Dot with this f of t. So dot with this f of b minus f of a, right? So this becomes the absolute value. So basically, the absolute value of z. Okay. Okay. So now let's combine what we have. So first we have phi b minus phi a is z dot with f prime x, and sorry, let's see z dot with f prime. So z dot with f prime x b minus a. Now notice that this is number, right? And the phi of b minus phi of a, which is a z squared. Okay, so the final step is what? The final step is that these two are combined, right? So now we have these two, right? So that's z squared is just basically z dot with a prime x, another vector, and the b minus a, right? So by the Cauchy-Schwarz, this guy is fixed, and then so this is greater or less or equal to z absolute value and f prime of x. By the way, if you don't know how to prove this Cauchy-Schwarz, you can go to my YouTube channel and type Cauchy-Schwarz. Okay, so b minus a this, right? So we can cancel one z, so you get z is less or equal to b minus a f prime of x absolute value. Okay, so now you can so now you have this, right? What is z, right? Z is just f of b minus f of a, right? So the difference in the vector is less or equal to b minus a at some points, the length of that derivative. So this is what we just proved. Okay, so this is just by Cauchy-Schwarz. Let's say maybe I spell it wrong. Yeah, sorry. Cauchy-Schwarz. SCHWART. Okay, so this is just what I want to say for the multi-value. Yeah, see you guys next videos.